AC circuit containing inductive coil only. AC circuit containing inductive coil only. In the circuit, an inductive coil of inductance cell is connected to an AC source of EMF equal E0 sin omega t, and a current, instantaneous current, is generated from the AC source, and that instantaneous current I and peak value of current I0 flows through the inductive coil of inductance cell. V subscript Li is the potential difference across the inductive coil of inductance cell, and VLI acts towards right in the direction of instantaneous current I, and we can denote the EMF induced across the inductive coil L. E is the small e is the EMF induced across the inductive coil L due to flow of varying current or due to flow of alternating current I through the coil L. When an AC source of EMF E equal E0 sin omega t is connected to an inductive coil of inductance of self-inductance L. When an AC source is connected to an inductive coil, the instantaneous voltage across the inductive coil, or inductor L is given by VLI will be equal to E. So inductive coil across L will be equal to E. That means VLI is instantaneous voltage that will be equal to instantaneous EMF E of the AC source. Again, an induced EMF E opposes the change in current flowing through the inductive coil of inductance L, and acts in the opposite direction with respect to the flow of instantaneous current I, and acts in the opposite direction of the instantaneous voltage VLI across the inductor L. Therefore, we can say that the instantaneous voltage across the inductive coil L will be equal to VLI will be equal to minus E, or E is equal to minus small e, and E0 sin omega t will be equal to minus small e, where small e is equal to minus L di by dt. That is, induced EMF across the inductor L is E, which is a minus L di by dt, and di by dt is the rate of change in current through the inductive coil of inductance L. Therefore, E0 sin omega t will be equal to minus under bracket minus L di by dt. E0 sin omega t is equal to minus under bracket minus L di by dt. Therefore, E0 sin omega t is equal to L di by dt, or di is equal to E0 divided by L sin omega t dt. E0 divided by L sin omega t dt. Therefore, I equal integration di. I is equal total current I is equal to integration di is equal to integration E0 by L sin omega t dt. E0 by L is taken outside integration, so E0 by L integration sin omega t dt. E0 by L under bracket minus cos omega t divided by omega, Therefore, I is equal to minus E0 divided by omega L cos omega t. I is equal to minus E0 divided by omega L into cos omega t equal minus E0 by omega L sin under bracket 90 degree minus omega t equal minus E0 by omega L under bracket minus sin omega t minus 90 degree is equal E0 by omega L sin under bracket omega t minus pi by 2 or 90 degree. Therefore, I, that is the instantaneous current I, is equal to I0 sin omega t minus pi by 2. I is equal to I0 sin omega t minus pi by 2. That is the instantaneous current flowing through the inductive coil of self-inductance L. I is equal to I0 sin omega t minus pi by 2, which is the instantaneous current flowing through the inductor L in an AC circuit containing inductive coil L only, where I0 is equal to E0 divided by omega L. Therefore, I0 is equal to E0 divided by X subscript L or XL. I0 is equal to E0 divided by XL. And in this case, XL will be equal to omega L, and XL will have the same dimension as that of resistance. I0 is equal to E0 by XL, which is the peak value of alternating current flowing through inductive coil L, and XL is equal to omega L. X subscript L is equal to omega L, where omega is the angular frequency of the alternating voltage. And if E0 is the voltage, then XL should have the same dimension as that of resistance. So voltage by resistance is equal to current. Voltage divided by resistance equal to current. That means XL will have the same dimension as that of the resistance. Therefore, XL is equal to omega L. That will be inductive reactance of the inductive coil of self-inductance L. XL is equal to omega L, which is the inductive reactance of the inductive coil of inductance L, which is the effective resistance, offered by the inductive coil L against the alternating current E equal E0 sin omega t, which is the effective resistance offered by the inductive coil or inductor against the alternating current. L offers a resistance XL, which is equal to omega L against the alternating current I equal I0 sin omega t. If E equal E0 sin omega t, then I will be equal to I0 sin omega t minus 90 degree or minus pi by 2. Therefore, phase difference between the current and voltage, the alternating voltage E, will be given by delta phi. That will be phase of current I, that is phi I, minus phase of voltage E, that is phi E. Here omega t minus pi by 2 is the phase of current phi I equal omega t minus pi by 2, and phase of voltage is omega t. Therefore, delta phi is equal to minus pi by 2. Delta phi is equal to minus pi by 2. That is the angular phase difference between the current and voltage for an AC circuit containing inductive coil L only. Therefore, the current I lags behind the voltage E. Current I lags behind the voltage E by a phase angle, or by a phase difference, by a phase angle of pi by 2 radian. Minus sign indicates that, negative sign indicates that current lags behind the voltage by a phase angle of pi by 2 radian. Therefore, current lags behind the voltage by a phase angle pi by 2 in an AC circuit containing inductive coil only or inductor only. Now we have to draw the phasor diagram of an AC circuit containing inductive coil L only. And here in the phasor diagram, is the diagram. We have to define what is phasor diagram. Here phasor diagram is the diagram in which the mathematical relations, that is E equal E0 sin omega t and I equal I0 sin omega t minus pi by 2, are represented by two triangles, the two right angle triangles. The phasor diagram is the diagram in which the mathematical relation between the voltage and current will be represented by the two right angle triangles to indicate the phase difference between the current and voltage, in the AC circuit containing inductive coil L only, containing inductive coil of inductance L only. Now we have drawn a right angle triangle ANO having angle omega t. The right angle triangle ANO will represent the voltage E equal E0 sin omega t of the AC source such that it hypotenuse OA is equal to E0, that is the peak value of voltage, and the perpendicular AN is the instantaneous voltage E. The triangle ANO represents the relation E equal E0 sin omega t such that the peak value of voltage E0 is equal to the hypotenuse OA and the instantaneous voltage E is equal to the perpendicular AN. E0 is equal to OA and E, instantaneous voltage E, is equal to the perpendicular AN. Now we can draw a straight line which will be perpendicular to the hypotenuse OA. That means this straight line will be perpendicular to the peak value of voltage E0. This is a straight line and that straight line is OB. OB is a straight line which lags behind a phase angle 90 degree. Lags behind a phase angle 90 degree, and that means this straight line OB will be perpendicular to the straight line OA and lags behind a phase angle of 90 degree. Now we can draw two perpendiculars from the point B. BM1 is a perpendicular on the horizontal axis and BM2 is a perpendicular from the point B on the vertical axis. I0 is the hypotenuse of the triangle BM2O or BM1O. As I0 is equal to OB and I0 is perpendicular to E0, that's why as I0 is equal to OB and I0 is perpendicular to E0, that's why the instantaneous current I will be equal to the perpendicular BM2, because BM2 is perpendicular to the another perpendicular AN of the larger triangle ANO. If I is equal to BM1, then BM1 will be parallel to AN, which is incorrect. That's why the instantaneous current I will be equal to the perpendicular BM2, as I0 is perpendicular to E0. That's why OB will be perpendicular to OA and I will be perpendicular to E. That's why BM2 will be perpendicular to AN. Therefore, in triangle BM2, therefore, the triangle BM2O represents the relation I is equal to I0 sin omega t minus pi by 2 such that I0 is equal to OB, that is the hypotenuse OB represents the peak value of current I0, and I, instantaneous current I, will be equal to the perpendicular BM2.